Today, we're doing a fun experiment to create artificial rain and understand the water cycle.
Prepare a glass jar, hot water, a clean plate, and some large ice cubes.
Pour hot water into the jar about 1/3 full, then place a plate on top.
Wait 1 minute for the plate to warm up. Then place ice cubes on top and start observing.
Watch the water vapor rising and sticking to the bottom of the cold plate.
Look! The droplets get bigger and start falling like rain.
Congratulations! You have just created a small rain inside your own glass jar.
Hot water evaporates and meets the cold surface, turning back into tiny water droplets.
When the droplets become heavy enough, gravity pulls them down, just like real rain.
This experiment helps us understand how clouds and rain form in the water cycle of our Earth.
Hello, kids. Let's explore the balloon race car experiment to learn about reaction force.
Prepare an empty plastic bottle for the body, 4 bottle caps for wheels, straws, and a balloon. First, attach the wheels to the plastic bottle to create a car that can roll. Attach a balloon to the end of a straw, then tape the straw firmly to the back of the car.
Inflate the balloon through the straw, then use your hand to seal the end to keep the air inside. Place the car on a flat floor, then release your hand to let the air escape from the balloon. The result is that the race car surged forward thanks to the powerful escaping airstream. According to Newton's third law, every action force always has an equal and opposite reaction force.
The air pushing backward creates a reaction force that pushes the car straight forward quickly.
The experiment vividly illustrates the movement principles of rockets and jet planes.
To experiment 28, where we will build a boat that moves using only soap and water.
To begin, gather your supplies: a shallow tray of water, a piece of thin cardboard, scissors, and liquid soap.
First, cut your cardboard into a boat shape, making sure to include a tiny notch at the back. Now, place your boat onto the water surface carefully, ensuring it stays flat and does not sink.
Get a small drop of dish soap ready on the tip of a toothpick or just your finger. Watch closely as we touch the soap to the water in the notch. The boat instantly shoots forward. The boat continues to cruise across the tray as the soap spreads across the surface of the water.
Let's see that again. It's amazing how a single drop of soap provides so much propulsion for our boat.
This happens because soap breaks the surface tension of the water, creating a force that pushes the boat.
Science is everywhere, even in your kitchen sink. Make sure to clean up your workspace when you finish.
Let's explore the colorful and exciting color-changing cabbage experiment right now.
Prepare fresh cabbage leaves, food coloring, filtered water, and clean transparent glass jars.
First, mix the food coloring into the glasses of water with the colors you love the most. Cut the base of the cabbage leaves, then place them into each glass of pre-mixed colored water.
Place the glasses in a cool place and wait for a few hours or overnight to see the change.
Carefully observe the color change on the leaf veins and the entire surface of the cabbage leaf. The result is that the cabbage leaves have turned into brilliant colors just like the water. Capillary action helps water move against gravity through tiny tubes in the stems and leaves. Color particles follow the water to nourish the leaves and stay behind, creating new colors. The experiment helps us understand how plants transport water and nutrients to nourish themselves.
Welcome to Experiment 21, where we explore how gummy bears react when submerged in vinegar. For this experiment, you will need a clear glass container, several gummy bears, and standard white vinegar.
First, we begin by setting up our base environment by filling our jar with the vinegar solution.
Now, we drop our subject into the liquid to initiate the chemical interaction between the candy and acid. Look closely as the acetic acid in the vinegar starts to break down the sugar and gelatin structure. Over several hours, the reaction intensifies as the bear swells significantly before starting to lose its structural integrity.
Notice how the once firm candy has now become a fragile, jelly-like mass that easily falls apart.
When compared to our starting point, the difference in size, texture, and color is quite remarkable and clear.
This happens because the acid disrupts the protein chains in the gelatin, causing the candy to dissolve completely.
That concludes our experiment, and remember to always clean your workspace and stay curious about the science around you.
Let's explore the CD hovercraft experiment to learn about air cushions.
Prepare an old CD, a plastic bottle cap, glue, and a large balloon. First, poke a small hole in the cap, then glue it firmly to the center of the CD.
Inflate the balloon, then stretch the neck over the cap you just glued to the disc. Place the CD on a flat, smooth table, then release your hand to let air escape.
Observe how the CD glides gently across the table, just like a real UFO.
The result is the CD moves very smoothly, thanks to a layer of air cushion underneath.
Air escaping from the balloon forms a thin film separating the disc from the flat table.
This air cushion minimizes friction, helping the object move much more easily. The experiment explains the operation of hovercrafts and modern air hockey tables.
Let's explore the artificial snow experiment to bring winter into the room.
Preparation: superabsorbent polymer powder taken from diapers, clean water, a bowl, and some food coloring.
Take the white powder from inside the diaper and put it into the bowl. Then slowly pour water in and stir evenly.
Observe how the polymer powder absorbs water extremely quickly and expands into soft, smooth, fluffy white granules.
Add a little bit of blue color if you want to create more sparkling and beautiful snow.
Use your hands to touch the mixture and feel the coolness and softness, just like real snowflakes. The result is that you have a bowl full of extremely fluffy and cool artificial snow to play with.
Superabsorbent polymer can absorb and retain a volume of water many times greater than its own mass. The special molecular structure creates a network that holds water molecules tightly inside the plastic.
The experiment introduces smart materials and their applications in modern life.
For this, you'll need 2 jars of water, some salt, a spoon, and of course, 2 eggs. Now, add about 6 tablespoons of salt into the second jar and stir until it dissolves.
Watch closely as the water changes density. This salt is our key activating ingredient.
Now, let's drop the eggs in. Notice the immediate difference in how they react. Even when I push it down, the egg bounces back. It's definitely floating now. Comparing them, our hypothesis was right. Salt changes how objects behave in water.
Salt water is denser than plain water, creating more upward force to hold the egg up.
That's the power of density. Thanks for joining me, and I'll see you next time.
Welcome to Experiment 30. Today, we are going to find out if an egg sinks or floats. Hello, kids. Let's explore the electromagnet experiment to understand electromagnetic fields.
Prepare a large iron nail, insulated copper wire, a battery, and metal paper clips. First, wrap the copper wire tightly and evenly around the body of the iron nail many times. Connect the two ends of the wire to the two terminals of the battery to create a current flow. Bring the tip of the nail close to the paper clips and observe the nail's ability to attract metal. Disconnect the wire from the battery and see if the paper clips still stick to the nail.
The result is that the nail becomes a magnet when there is electricity and loses magnetism without it.
The current flowing through the copper coil creates a strong magnetic field focused in the iron core. Electromagnetism helps transform electrical energy into magnetic field energy very efficiently.
This illustrates the operating principle of modern electric motors and loudspeakers today. Let's explore the transpiration experiment to understand the life of green plants.
Prepare a plant in a pot, a transparent plastic bag, and a piece of string to tie it securely.
First, choose a branch with many healthy green leaves and cover it with the plastic bag. Tie the bag opening tightly to the branch so that outside air cannot get inside. Place the potted plant out in the sun and wait for a few hours to observe.
Observe the strange phenomena happening on the inner surface of the transparent plastic bag.
The final result is many tiny water droplets that have successfully condensed on the inside of the plastic bag around the green leaves and the branch.
Plants carry out transpiration through small pores called stomata on the underside of leaves.
Water vapor from the leaves meets the closed space of the bag and condenses into droplets.
The experiment proves that plants are always exchanging water with the surrounding air.